In this lecture, we're going to discuss ionic bonding. Now, that's the first type of chemical bonding that we're going to discuss. And ionic bonding is basically, we've already discussed previously that unlike charges, attract each other. And we also discussed that like charges repel each other. So positive charges are going to attract negative charges, and we've done why ions are formed, because ions are formed so that elements can have stable electronic configurations. Now, if there are ions, then there would be positive ions and there would be negative ions. So ionic bonding is basically the electrostatic force of attraction between oppositely charged ions. So it's the force of attraction. You have a positive ion and you have a negative ion. A positive ion is called the chemical. There's another name given to a positive ion, which is called a cation, and you have a negative ion, which is called an anion, and there would be a force of attraction between these positive and negative ions, and this force of attraction would be called the electrostatic force, which would keep the two ions sticking together because they would be attracting each other. So how are ionic bonds formed? We can start with a very simple case. Remember, this ionic bonds are formed between positive ions and between negative ions. One thing to remember is that mostly positive ions are formed by metals, and negative ions are generally formed by non-metals. So in other words, what we can describe ionic bonding is it's the bond formed between metals and non-metals. So metals are going to bond with non-metals and they're going to form ionic bonds. Now, metals or positive ions are formed by group 1 elements, they are formed by group 2 elements, they are formed by group 3, which forms plus 3 ions, plus you have transition metals, which also form positive ions, whereas negative ions are formed by non-metals, and non-metals start with group 4 is a non-metal, it contains non-metals. Group 5 are also non-metals, group 6 are non-metals, and group 7 contain non-metals. But this is a very rough generalization. Generally what happens is, on the left hand side of the periodic table you have metals, and on the right hand side of the periodic table you have non-metals, and in the middle the transition from metals to non-metals, if you look across the periodic table, is not very it's a very gradual transition. It's not there's Now here's a rough representation of periodic table drawn in one of the books that I have. What you can see is that there's a staircase line that starts from boron. This element over here in group 3, it's boron, and the staircase continues till the end. You can copy this and remember that elements on the left hand side of the periodic table are metals, and elements on the right hand side of this particular line are classified broadly as non-metals, although the distinction over here is very blurred. The left hand side are strongly metals, the right hand side are strongly excluding group 8 or group 0, The right hand side are strongly non-metals. They strongly form negative ions. These ones strongly form positive ions. They just group 1 just needs to lose 1 electron. Group 7 just needs to gain 1 electron. The middle ones are the ones that get confused about gaining and losing electrons. So these are also called metalloids because they have both metallic and non-metallic properties. But for O levels, a simple classification would be the staircase line. So find a group 3 in your periodic table, and in group 3 find boron, and this element over here is boron. Then start drawing a staircase line and extend it all the way down. The left hand side would be metals and the right hand side would be non-metals. Now I will explain ionic bonding by taking an example, and let's pick an example. I've told you that ionic bonding is between a metal and a non-metal. So we can pick one metal. We can pick metal from group 1. We have lithium, which is 3 and 7, and it's in group 1. And I have let's pick a non-metal from group 7. We have fluorine, which is 9 and 19, and it's in group 7. The electronic configuration for lithium would be, there would be 3 electrons in total, and those 3 electrons would be arranged. There would be 2 electrons in the inner shell, and there would be 1 electron in the outermost shell. In fluorine, there would be a total of 9 electrons, and their arrangement would be, there would be 2 electrons in the inner shell, and there would be 7 electrons in the outermost shell. We can draw the 2 atoms. There is this is a lithium nucleus, and it has 3 protons and 7 minus 3, that means it has 4 neutrons. It has 2 electrons in the inner shell, so I'm drawing the inner shell now. So there are 2 electrons in the inner shell, and there is 1 electron in the outermost shell. We can then draw the structure of a fluorine atom. Fluorine would be, this is the nucleus of a fluorine atom. It has 9 protons and 19 minus 9, that means it has 10 neutrons in total. So there are a total of 9 electrons. There are 2 electrons are in the inner shell, so here are your 2 electrons in the inner shell, and there are 7 electrons in the second shell, which is the outermost shell. So we have 7 electrons in the outermost shell of fluorine. Now if you observe these 2 atoms, both of them are unstable. This is unstable, it does not have a complete outer shell. This one is also unstable, it's not having a complete outer shell. To become stable, what lithium needs to do is, it needs to lose 1 electron. Whereas what fluorine needs is, it has 7 electrons in its outer shell, so fluorine needs to gain 1 electron. So this needs 1 electron, whereas this is going to lose 1 electron. Eventually what happens is, this electron is lost and this electron ends up with fluorine. I'm going to redraw this now. After lithium loses 1 electron, what happens is, this was the lithium nucleus. It had 3 protons and it had 4 neutrons. So since lithium lost its outermost electron. So it's now left with just 2 electrons, and since it lost 1 electron, it's going to have a net charge on it, which would be plus 1. So this is lithium plus 1 ion. And what's going to happen to fluorine is fluorine had 9 protons, it had 10 neutrons, it had 2 electrons. In its inner shell. I'm going to use a different symbol now, and remember these are called dot and cross diagrams. The reason why they're called dot and cross diagrams is that you represent the electrons of one element by a dot and the other element with another symbol, which is generally used as a cross. So I'm going to draw the electrons of fluorine now with crosses. So there are 2 electrons in the inner shell, and there are 7 electrons. There were 7 electrons in the outer shell, but what happens is one of the electrons that lithium lost has now been used to stabilize fluorine. Now fluorine becomes -1, so it's going to have square brackets around it because it has gained 1 electron, and I've kept the symbol as a circle, as a dot. The reason is that that electron came from lithium. So lithium is now stable and fluorine is also now stable. So lithium is going to have a charge of -1. So this is what the dot and cross diagram for an ionic bond between lithium and fluorine would look like. And the formula of this, since lithium is positive and fluorine is negative, they're both going to attract each other. So there's going to be a force of attraction, and that force of attraction, which is an electrostatic force of attraction, that's basically called an ionic bond. It's the force of attraction between a positive ion and a negative ion, which is going to keep the two together. The way to write the formula of this is Li was +1, F was -1, so you would write LiF. The new molecule would be LiF, and LiF, the name of LiF, lithium would remain as lithium, whereas fluorine would change to fluoride. There are a few conventions that we follow when we try to name ionic compounds. The positive ion is written first, and the negative ion is always written second. So lithium would always be written first, and even when you're writing symbols or you're writing the name, it's always going to be written first. The second is it applies for negative ions. The negative ions, the name would change and it would end with IDE. This would be used to end the name. So if you have fluorine, it would change to fluoride. If you have oxygen, it would change to oxide. If you have nitrogen, it forms an ion, it's going to become nitride. Then you have sulfide, chlorides, bromides, etc. So whenever there's IDE written, that means you're talking about not the element but the negative ion of that element. Now we can do another example of an ionic bond, a dot and cross diagram for an ionic bond. We can pick another metal and a non-metal. A metal could be, let's pick one from group 2 now, and it could be magnesium, which has 12, the proton number is 12 and the atomic mass is 24. And the non-metal could be of group 6, and we can pick oxygen, which has 18, the proton number is 8 and the atomic mass is 16. So we're going to draw a dot and cross diagram between magnesium and oxygen. First we need to find out how many electrons. Magnesium has a total of 12 electrons, and the electronic arrangement would be there would be 2 electrons in the first shell, 8 in the second, and 2 in the outermost shell. It's in group 2. Group 2 have 2 electrons in the valence shell. Group 6 have 6 electrons in the valence shell. Let's confirm that it has 8 electrons, oxygen, and the electronic configuration would be there would be 2 electrons in the inner shell, the first shell, and there would be 6 electrons in the outermost shell. Now let's draw the dotted. Let's first draw the atoms. I'm drawing magnesium. It has 12 protons, and 24 minus 12, it has 12 neutrons. And let's draw the two electrons in the first shell. There are 8 electrons in the second, and there are there are 2 electrons in the outermost shell. So that is your magnesium atom. And similarly, we can draw oxygen. Oxygen is going to have, this is the nucleus. It's going to have 8 protons. The proton number is 8, and 16 minus 8, that's also 8. It's going to have 8 neutrons. So there are 8 protons, 8 neutrons in the nucleus. And let's draw the first shell. The first shell has 2 electrons, so we're going to draw 2 crosses. The electrons of oxygen are going to be represented by crosses. The second shell is going to accommodate it's going to accommodate 6 electrons. So there are a total of 6 electrons in oxygen. So these are the 2 atoms, and if you look carefully, both of them have unstable configuration. This is unstable. It does not have complete outer shell. This is also unstable. It's not having a complete outer shell. This needs to lose 2 electrons. It has 2 electrons. Group 2 always loses 2 electrons. So to become stable, it needs to lose 2 electrons. And for oxygen to become stable, it has 6 electrons in its outer shell. It needs 8. So it needs to gain 2 electrons. So this needs to lose 2 electrons, and oxygen needs to gain 2 electrons. We can redraw this. These 2 electrons, what eventually basically ends up happening is these 2 electrons that magnesium has in its outermost shell are going to be lost, and they're going to end up with oxygen. And we can redraw this. Magnesium would lose its outer shell. So there were 12 protons and there were 12 neutrons. The first shell had 2 electrons, and the second shell is going to have going to have 8 electrons. And previously there were 12 electrons. There were 2 more electrons in the outermost shell, but it has lost those 2 electrons. So when something loses 2 electrons, it's going to become positively charged. So it's going to have a +2 charge. You would have to draw square brackets around it to write +2. So magnesium, this was the magnesium atom. Previously it lost those 2 electrons. When it lost those 2 electrons, it became +2 and lost its outermost shell. On the other hand, oxygen had 8 protons and it had 8 neutrons. There are 2 electrons in the inner shell. and it had 6 electrons previously in its outermost shell, but 2 electrons are going to come from magnesium, because magnesium is losing 2 electrons, oxygen needs 2 electrons. So 2 electrons would end up with oxygen, and they would be drawn with dots because they're coming from magnesium. And you're going to, since it's gaining 2 electrons, you're going to draw square brackets around it, and -2 would be the charge on oxygen. So you'll have an oxygen ion O -2, and you'll have a magnesium ion which would be Mg +2. Now if I want to write the formula for this would be MgO, because there's one magnesium ion, there's one oxygen ion, and the name would be magnesium would still be magnesium, but oxygen would become, because the oxygen is forming a negative ion, it would become oxide. So this is an oxide ion. Now let's do a third example of a dotting cross diagram for an ionic compound. The metal that we are going to choose, an ionic bond would be formed between a metal and a non-metal, and this time I'm going to pick a metal from group 3. And if you look at group 3 in the periodic table, aluminium, I'm picking aluminium. Aluminium is 13 and 27, and I'm going to pick a non-metal from group 5. Now in group 5 I have nitrogen. Nitrogen is 7 and 14. So this ionic bond will be made between aluminium and nitrogen. Aluminium has 13 electrons, so the electronic configuration for aluminium would be, it would be 2 electrons in the inner shell, 8 in the second shell, and 3 in the outermost shell. Whereas for nitrogen, the electronic configuration would be, it has a total of 7 electrons, so the electronic configuration is going to be 2 electrons in the inner shell, and there would be just 5 electrons in the second shell. We can draw the atomic structure of the 2 atoms first. And I'm going to draw the atomic structure of aluminium. This is the nucleus. It has 13 protons, and 27 minus 13, it has 14 neutrons. And the electronic configuration would be, there would be 2 electrons in the first shell, and there would be there would be 8 electrons in the second shell, and you would have 3 so there would be 3 electrons in the last shell. So I've drawn 3 electrons in the last shell. Similarly for nitrogen, there would be nitrogen has 7 protons, and 14 minus 7, that's also 7, so there are 7 neutrons in the nucleus of nitrogen. There would be 2 electrons in the first shell, and there would be 5 electrons in the there would be 5 electrons in the second shell. Let me draw these electrons with crosses, because one element, the electrons of one element would be represented by dots, and the other element would be represented by crosses. So I've drawn the electrons of nitrogen with crosses. Now both of these electronic configurations are unstable. This is unstable, and to become stable, this is also unstable. It has an incomplete outer shell. Both elements have incomplete outer shells. Now to become stable, aluminium would need to, it has 3 electrons extra, so it would need to get rid of these it would need to get rid of these 3 outer electrons. So it needs to lose 3 electrons. On the other hand, you have nitrogen. It has a total of 5 electrons in its outer shell, and to complete its outer shell it needs to gain 3 electrons. So aluminum needs to lose 3 electrons, whereas nitrogen needs to gain 3 electrons. And we can redraw this. We can redraw both atoms, and redrawing both atoms, this is the nucleus of aluminum, having 13 protons and 14 neutrons. The first shell contains 2 electrons drawn with dots. The second shell contains 8 electrons, and we've removed the last shell. The 3 electrons are now lost. So if they are lost, then that means if it loses 3 electrons, it's going to have a complete outer shell, but losing 3 electrons will result in a +3 charge on it. So that's aluminum having a +3 charge, and that's a stable electronic configuration. On the other hand, you have nitrogen, which has 7 protons and it has 7 neutrons. Nitrogen has 2 electrons in its inner shell, and now these 2 electrons should be drawn with crosses. So it has 2 electrons in its inner shell, and it has 5 electrons in its outer shell. And since nitrogen needed 3 electrons, so the electrons that were lost by aluminum would be gained by nitrogen. So nitrogen ends up gaining those 3 electrons that were lost, and now nitrogen has a stable electronic configuration. And since it is gaining 3 electrons, that means it would have a charge of -3, and nitrogen would have, the symbol would be written as, this would be a nitrogen ion, which would have a charge of -3. And to write the formula of this compound, it would be, there's 1 aluminum and there's 1 nitrogen ion, so it's Aln, and the name would be aluminum, would remain as aluminum, whereas nitrogen, if it forms a negative ion, would become nitride.